basic concepts of sequence and looked upon AB and GP in the previous classes. We are going to be looking at what we call series in this class. So we're going to talk about series. So the question is, what is series? So because the basic thing about what we're supposed to know in mathematics is definition. So what is series? So series can simply be defined as the sum total of the terms in a sequence. When you add up the terms in a sequence together, it is then called series. That's what it's called. For instance, if the terms of a sequence is x1, x2, x3, x4, x5, all the way down, the moment it becomes x1 plus x2 plus x3 plus x4 plus x5 plus all the way down, it's this one on the top is called sequence, while this is called series. When I'm adding the terms in a sequence together, it is being referred to as series. So I'm going to take examples. Unlike sequence, where I said that this can be noted. I remember I told you that this can be noted using x subscript n, or you can say x subscript I starting from 1 all the way down to n. This is represented using the summation of I. Well, let me put xn here so it can make sense. Let's say we have xn here, and we also have xn as the last term here. When I'm adding up all of these terms together, it means I starts from 1, I is starting from 1, all the way down to n, all the way down to the end of xi. This is summation. So I'm writing all of these guys in a more compact form, and all of this in a more compact form. So writing this is synonymous as writing this, and writing this is synonymous as writing this. It's a compact form of writing them on a more concise way. Do you understand? So that is that for that. So I'm going to take one or two examples on that sequence. Sorry, another series now. Then in next class we're going to talk about the arithmetic series and the geometric series. So let's take an example. Now, to take an example on that series, we'll consider the following question. So solve the following. Solve the following. This is an example. Imagine we are given the summation of I starting from 1 all the way down to 4 of, say, x squared. And number 2, imagine we are given the summation of I starting from, I'm going to say x, pardon me, x is this one. And then let's say we have p starting from 0 all the way down to 3 of 1 over p. Then 1 over 3. I like to tweak my variables so that you don't think that mathematics is only equivalent to x and y. That's why I like changing them many times. So we have summation of, let's say, w starting from -1 all the way down to 4 of 1 minus w of this form. Then let me add one more that I believe will be your own assessment. The summation of I, or let's say k, starting from 0 all the way down to 5 of k raised to the power of k. So you can do this for yourself. So let's take the solution one or the other. We just take 3. So, okay, I'll take 3. I'll try to take 3. Let's see what our solution. Number 1, I have the summation of what? Of I of x starting from 1 all the way down to 4 of x squared. Please kindly follow me carefully. Nothing is difficult. It simply means that this can be expressed as, don't forget that our x start from 1 and it end at 4. For the sake of comprehension, I'm going to go this way. I will say you write x squared, and then you could simply put a slash and put x equals to 1 here, plus write another x squared. You can put a slash here and put x equals to 2, plus you can write x squared again, put a slash here and say x equals to 3, plus you can write x squared, put a slash here and say x equals to 4. I start from 1 and end at 4 based on the function given here. And this is summation. Summation is plus, plus, plus. So substitution this time, whenever I see x equals 1, I put 1, then it becomes 1 squared plus 2, 2 squared plus 3, 3 squared plus 4, 4 squared. And that becomes 1 plus 4 plus 9 plus 16, and that equals to 30. Eventually, that check it out, that is 30. So it's easy to do and easy to understand. So let's see Roman figure 2. I have the summation of p starting from 0 and enter 3 of 1 over p. I follow the same process. That's what make mark unique and different. I just need to say 1 over p, then p being 0 plus 1 over p, then p being 1, then 1 over p, then p being 2, then 1 over p, then p being 3. So I start from 0 and it enters 3, just as I have on the board. So whenever I see p, I'll put 0. Oh, there's something I would love to avoid. So please, because I am not trying to explain this concept now, please, I'm going to be starting my p this time from 1. Please. Because anything that 0 is infinity, and I'm going to go out now, so you don't get confused. So I'm going to wipe this off entirely, so that the result is 1 to 3 only. So I'll now have what? I'll now have 1 over 1 plus 1 over 2 plus 1 over 3. Because whenever I see p, I put 1, I put 2, I put 3. Now I wiped off that one that has 0 because 1 over 0 equals infinity, which is another concept. I don't start explaining to you how infinity plus this plus equals infinity. That's how I want to just start it off. Sorry for that. So I have LCM of 1, 2, and 6. 1, 2, and 3 is simply 6. 1 is 6 is 6. 6 times 1 is 6. Plus 2 is 6 is 3. 3 times 1 is 3. Then 3 is 2. Then is 2. Simply add it up and have 9, 11 over 6 as my answer. And that is done without stress. Just without stress. So I know that is clear enough. I'm going to take number 3, and perhaps I may have one more class up for you to try out. So let me just explain this so I think